Hello my dear learners, today I will discuss a very important mode of propagation in the topic of radio wave propagation, which is known as the surface wave propagation or ground wave propagation. As I have already told you that there are basic three modes of propagation in the radio wave propagation. They are known as ground wave surface wave propagation, sky wave propagation and space wave propagation or line of sight propagation. So, in my today's lecture I will focus on the first mode of propagation as ground wave or sky wave propagation. So, let us start the topic of ground wave or surface wave propagation. What is ground wave propagation or surface wave propagation? First of all, as we classify the modes of propagation on the basis of the frequency range, the frequency of the signals which can be applicable in the category of ground wave or surface wave propagation. This is the frequency range maximum up to 2 megahertz only. This is the mode of propagation which is restricted or limited by the frequencies of the signals as 2 megahertz. The waves which while travelling they glide over the earth's surface, they are known as the ground wave. As I have already told you that the name ground wave or surface wave exactly replicates with the ground or earth or surface of the earth, and the movement of these surface waves or ground waves is according to the curvature of the earth. That is why we can say that these waves are gliding over the earth's surface according to the curvature of the earth. The ground wave is also called as surface waves as the wave passes over the surface of the earth. The ground waves are always vertically polarized, which can be produced by vertical antennas. In the topic of polarization, I have cleared the concept of vertically polarized waves and horizontally polarized waves. How the radiation pattern can be found, the different designers of the antenna can identify the polarization of the different kind of antennas. The antennas which are in the form of tower radiators, the antennas which are always kept longitudinally to the earth's surface are producing the vertically polarized waves in the atmosphere, and the electromagnetic waves which are vertically polarized, generally they all are in the effect of ground. That is why we can say that all the antennas which are utilizing the ground wave propagation or surface wave propagation as their mode of propagation for the communication of electromagnetic waves or radio waves are vertically polarized waves producers or vertically polarized antennas. They are in the form of tower radiators or vertical antennas. Any horizontal component of the electric field vectors in the contact with the ground gets short circuited. This is the condition of vertically polarized waves. So, when the ground waves propagate along the surface of the earth, the charges are induced on the earth's surface. The number and polarity of these charges keep on changing with the intensity and location of the wave field, and this variation causes the constitution of a current. That is why the earth can be considered as a leaky capacitor in the case of ground wave propagation or surface wave propagation. And this phenomena, when the earth or surface of the ground represents as the leaky capacitor, it can be represented like this. This is the capacitance, this is the resistance, and when it is representing the mode of propagation surface wave like this. When the surface waves are utilizing by the earth's surface, it behaves like a leaky capacitor. As the wave travel over the surface, it gets weakened due to absorption of some of its energy. This is known as the ground loss. When the surface wave or ground waves are propagating above the earth's surface, some of the signal's strength is extracted by the ground and it is shown in the form of ground loss. And the ground loss is a very important factor, it is a very important phenomena in the surface wave propagation or ground wave propagation. Just because of the limitation of higher ground losses in the higher frequency electromagnetic signals, the surface wave or ground wave propagation cannot be utilized for the higher frequency range signals in the radio wave propagation. So, this is one of the most important limitation of the ground wave propagation. This absorption in fact is the power loss in the earth's resistance due to the flow of current. Obviously, when the power is lost from the signal's strength, then this will be represented in the form of the resistance, means in the form of I square R. So, this energy loss is partially replenished by the diffraction of energy downward from the portion of the wave present somewhat above the immediate surface of the earth, and this process is shown in the figure. When we show this particular diagram in the two views, first one is side view and the second one is front view, you can say that the surface waves in the surface of the earth are representing the different kind of behavior in the terms of radio wave propagation. So, simply you can identify from these figures. The earth's attenuation increases as frequency increases. I have already mentioned this thing. So, this mode of propagation is suitable for low and medium frequency only for up to 2 megahertz, means VLF, LF and some of the medium frequency bands are utilizing the ground wave or surface wave propagation for their mode of radio wave propagation. It is also called as medium wave propagation. All the broadcast signal received during daytime is due to the ground wave propagation. The very important characteristic or application of medium frequency band is to utilize these signals in the category of broadcasting, especially in the AM broadcasting. So, very important application of surface wave or ground wave propagation is dedicated to the AM broadcasting. As the ground wave propagation over a surface of the earth, the wave front gradually tilts more and more. As the wave front tilts more and more, the more electric field components get short circuited, and this particular condition can be experienced by the tilting of the wave front through the ground surface of the earth. And this is a very important concept when the curvature of the earth comes into account for the surface wave or ground wave propagation. How it works you can see here. The strength of the signal gradually decreases with increase in the tilt. How? Why this tilting happens? This tilting happens just because of the curved surface of the earth. When the curve is more, obviously the tilting is more, means the tilt angle is known as the angle between the wave front at that point of the earth surface with respect to its longitudinal wave front. The angle between these two is known as the tilt angle, and you can see here that these are the different tilt angle for the different wave front at the different position on the earth's surface. So, this particular phenomena tilting is a important concept in the surface wave or ground wave propagation. How it happens? You can see here the phenomena of wave tilting in successive wave front is shown here, in which T1, T2, T3, T4, T5 are tilting angles in increasing order, and W1, W2, W3, W4, W5 are the different wave fronts. You can see here that T2 is greater than T1, T3 is greater than T2, T4 is greater than T3 and T5. The different kind of different at different positions, when we talk about the different wave fronts, they are having the different tilt angle, and as the tilt angle is increasing, the obviously the signal strength is also decreasing. These are the salient features of the ground wave propagation. Obviously, the most important limitation or the factor of ground wave propagation is the ground loss. So, simply ground wave propagates along the surface of the earth. When the ground wave propagate along the surface of the earth, the charges are induced on the surface of the earth, and these charges travel along the wave, and hence the current gets reduced, and this induced current is reflecting in the form of ground wave losses. While carrying induced current, the earth acts like a leaky capacitor, and the ground waves are produced in vertically polarized antennas, which are placed very close to the surface of the earth. All the vertical antennas are in the effect of ground. In general, the surface of the earth is considered to be a plane if the distance between the transmitter and receiver is less than the minimum barrier distance d given by this expression. The minimum barrier distance is the distance at which the distance between the transmitter and receiver, and this the distance must be less than the minimum barrier distance, which is given as d is equal to 50 upon frequency in megahertz to the power of 1 by 3. The variation in surface of types of earth affect propagation loss considerably. Obviously, the different characteristics of the earth's surface impacts the mode of propagation, impacts the ground wave propagation or surface wave propagation. The maximum range of ground wave propagation depends on the frequency and power of the transmitter. When the power of the transmitter is increased, obviously the distance between the transmitting and receiving end can also be increased, because as the ground losses are taken from the transmitted power, then obviously when the power is high, the distance can also be increased. Lower frequency between 30 and 3000 kilohertz vertically polarized radio waves can travel as surface waves following the contours of the earth, and this is called ground wave propagation. So, in this mode of radio wave propagation, the wave propagates by interacting with the conductive surface of the earth, and the wave clings to the surface and thus follows the curvature of the earth. So, ground waves can travel over mountains and beyond the horizon. The ground waves are important at broadcast and lower frequencies, and these can be used up to 2 megahertz. According to the characteristics of the earth, the strength of the ground wave varies, and these waves are not affected by the changes in the atmospheric conditions. So, this is a very important concept of ground wave propagation. Generally, we use this mode of propagation for lower frequencies only, and all the applications which are utilized under this category are summarized here. Ground wave propagate in vertical polarization. So, vertical antenna generally known as monopoles. Obviously, the tower radiators or vertical antennas in the form of transmitting antennas, they prefer the monopoles type of antennas configuration, and these are generally required in the surface wave or ground wave propagation. since the ground is not a perfect electrical conductor, ground waves are attenuated as they follow the earth's surface. Attenuation is proportional to the frequency. Obviously, you know about the attenuation. Attenuation is a form of loss, signal loss, where the more attenuation is held, the more loss of the signal is happening. So, simply the main mode of propagation at lower frequencies is this surface wave or ground wave propagation in the MF, LF and VLF bands only. Ground waves are used by radio broadcasting stations in the MF and LF band and for the time signals and radio navigation systems. Here I would like to mention one thing, that over the like surface wave or ground wave propagation, obviously the water surface or sea surface also plays very important role in this mode of propagation, where the signal strength does not decrease very rapidly as in the case of surface of the earth, because water surface or sea surface cannot extend their losses very much as compared to the surface of the earth. That is why we can utilize the higher frequencies on the water surface in the ground wave or surface wave propagation. So, simply harbor telephony or the communication between the ships can be occurred with the mode of propagation for higher frequencies of signals also. So, when we talk about the different applications of ground wave or surface wave propagation, generally the bands which are useful in this category, as we know that VLF, LF and MF. The different applications of very low frequency band in electromagnetic spectrum, they are first of all the most important concept of communication was given by the Graham Bell, and when the worldwide telegraphy or telephony was invented, all these applications were using the frequencies in the VLF and LF band only. So, the starting era, the early era of the communication was based completely on the VLF and LF band. So, most of the applications, especially when I mention the submarines or the communication in the harbors. So, the applications in the low frequency bands are utilizing the surface wave propagation or ground wave propagation in this category. The different kind of more specific applications are given here, like early long distance radio communication, like wireless telegraphy. Obviously, telegraphy was the first application in communication and it was really an early era long distance communication application, which was utilizing the surface wave propagation or ground wave propagation for establishing its communication between a transmitter to the receiver. A very important discussion is based on the frequency limitation in the ground wave. Why the frequencies above 3 megahertz are not utilized in the ground wave or surface wave propagation? The answer is only that the ground losses in the higher frequencies are so much higher that the frequency, those signals of higher frequencies cannot survive in the ground wave propagation. They cannot travel along the curvature of the earth, they cannot glide over the surface of the earth. That is why they cannot be a part of ground wave or surface wave propagation. So, we have to adopt some more the different concept of mode of propagation for the higher frequency signals in the radio wave propagation, and this mode is known as the skyway propagation or ionospheric mode of propagation. As I have already told you about the structure of the atmosphere, that it plays a very important role in the radio wave propagation. So, the different layers, the different position of the different layers of the atmosphere are very important in the concept of radio wave propagation. So, we will study the second mode of propagation as skyway propagation in my next lecture. So, I am delivering this lecture for the ground wave or surface wave propagation. In my next lecture, I will discuss the skyway propagation, ionospheric propagation. So, thank you very much for watching this video. I will discuss some more important concepts related to skyway propagation in my next lecture. Thank you very much.